So we have the displacement time graphs, like example, as I gave an example of the first few motions. So if an object is moving at a constant speed, constant velocity, I mean, so four graphs are possible. I'll just re-explain the idea. Like four possibilities are there. On x-axis, we have the time. On the y-axis, we have the displacement. So this is the displacement and time. Same thing, displacement in meter. Time is there in second. Displacement in meter. Time is there in second. And displacement in meter and time in second. The first one I drew in this manner. This was the first example, the second example, the third example, and the fourth example. Okay. All of these are what? These are all constant velocities. That is one thing. You understand it's a constant velocity because the slope or the gradient is constant. But the second thing is direction of the velocity. Like for the first example, what about the direction of the velocity? Like the velocity is positive or negative. So when we draw the line, this one is y1 and this one is y2. So what does it mean? Like if this is our origin, the point where we are observing an object, the object is moving towards right with a constant speed. Like this, the direction of the motion is towards the right, and the displacement, when we measure the displacement, will also get, so the velocity is positive as well as the velocity is constant. What about this one? If you have the origin, so what it shows when we draw the line, this will be y1 and this will be y2. The displacement is increasing. It means the object is going away from the origin, but on the left hand side. So the direction of the velocity is towards left. That's why we took as a negative velocity. Here, the direction of the velocity is toward the right. That's why we called as a positive velocity. Now let's come to the third example, which is also a constant. Say this is the origin and the object is, say, certain distance from us. Here is an object. So when we say about the displacement, displacement is a distance from the origin which we measure. So when we draw an arrow for the displacement will be positive. There's a positive because it's on the right hand side, so the displacement is positive. What about the value of the velocity? When we work out the value of the velocity, the v1, y1 is above y2. So if the y1 is above y2, it means the velocity will be negative. So how the velocity is negative? It shows that the object is moving towards the origin. So the direction of the velocity is towards left. Because the direction of the velocity is towards left, that's why the velocity is negative. But whenever like we measure the displacement, we measure from the origin. So from the origin, the object is always toward the right hand side. That's why the displacement is positive. And the last example, the object is, if we have an origin, so this is the origin, the object is on the left hand side of the origin. That's why the displacement is negative. And the object is moving towards the origin because the displacement is decreasing. So if an object is approaching or moving towards the origin, velocity is positive. And when we work out the gradient, so this will be y1 and this will be y2. So the y2 is above y1. So if the y2 is above y1, it means the velocity will be positive. So it has a constant velocity which is positive because it's moving towards right, and the displacement, the original displacement is toward left. That's why the displacement was negative. Is it clear? The four examples of the constant velocity in terms of the motion. Any question or doubt at this point? This is for the constant velocity. The next one, we have the graphs for increasing velocity. So if you want to sketch a graph for the increasing velocities, again, 4 possible graphs are there. The slope of a displacement time graph represent the velocity. So that means the slope should increase. So we have a displacement on y-axis, time, displacement, time, displacement, time, and we have a displacement in time. If I draw a graph like this, the slope should increase. So slope is increasing, as you can see, the angle gets steeper. But what about the value? So here velocity is increasing, but what about the value of the velocity? Is it positive or negative? Is it positive or negative? So when we
Positive.
draw, good. So when we draw the line, this will be y1 and this will be y2. So the y2 is above y1. It means the velocity of this one is positive. So slope is increasing. That's why velocity is increasing and the velocity will be positive. If I draw the same graph, but the negative displacement, so as you can see, for this one also, it's a slope is increasing. The angle with the x-axis is increasing. And what about the value? So when we take the value here, this will be y1 and this will be y2. So the y1 is above y2. So it means the velocity is increasing, but the velocity will be negative. So velocity is increasing and it is negative. Same thing, we can also have a displacement graph like this. What happened to the slope? The slope is increasing. How you understand the slope is increasing? If I draw the x-axis here, the red line, and I draw the x-axis here. So you can clearly see that the angle with the x-axis is increasing. Angle below the x-axis, if I draw, you can see the angle is increasing. So it means if the angle increase, it means the slope is also increasing. But what about the value of this slope? Is it positive or negative? What about the value of this slope? Is it positive or negative? So when I draw the
Negative.
line, negative. So this will be y1 and this will be y2. So y1 is above y2. If y1 is above y2, it means it should be negative. So this velocity will increase, but negative. And if we have a graph like this, so if we draw the x-axis, as you can see, the angle at this point and the angle at this point. So if you draw theta here and at this point the angle is increasing, if the angle is increasing, it means the slope is increasing. And what about the value of this slope? When you take y1 and you take y2, so the y2 is above y1, so it means the velocity will be positive. So velocity is positive and increasing. Is it clear? The increasing velocity graphs and
Yes, sir.
the value of the velocity. Anyone having a doubt or question till this point? No doubt till this point. Then we have the decreasing velocities, a similar graphs, but the slope should decrease. So first thing you should understand what happened to the slope, and the second thing is the value of the slope, is it positive or negative? Because why it is important to know the value, like whether it's positive or negative, as in the exam you will have the question in which using a displacement time graph you have to sketch a velocity time graph. So you should understand the shapes of the graph, and according to that you can only sketch the velocity time graph. So if we have a displacement and time for decreasing velocities and displacement in time for decreasing velocity, displacement in time for decreasing velocity, and displacement in time for decreasing velocity. All of them are decreasing velocities, but the value is important. When I work out the value of velocity, what will the value of velocity have? Positive or negative?
Positive.
Positive, because when I draw y1 and y2, so the y2 is above y1, that's why it will be positive. What about this one?
Negative.
So this will be negative. What about this one?
Negative.
So this will be negative velocity. And what about the last one?
Positive.
Positive. So you can work out these are the possible shapes of the graph. There is no other shape they can make. These are the possible shapes of the graphs, the displacement time graphs. Now, what is the use of using this displacement time graph? So using the displacement time graph, we can work out the velocities. Using the displacement time graph, we can work out the velocity, then the average velocity or instantaneous velocity. Instantaneous velocity means velocity at a particular moment of a time. So if it's a straight line, then we just work out the gradient. But if we have a displacement time graph, so first, what happened to velocity? The trend. What happened to velocity here? Increasing, decreasing, constant, zero.
Decreasing.
The velocity is decreasing. And what should be the value of the velocity I should get when I solve?
Positive.
I'll get a positive value. So if I want, like example, you have 1, 2, 3, 4, 5, and we have the numbers, like example, 10, 20, 30, and so on. And the question is calculate the velocity at the time t is equals to 2 seconds. So how to work out that at the time t is equals to 2 seconds? So we'll mark a point where time is 2. Okay. And we will draw a line, a tangent, which should only touch that specific point where we want a speed, velocity. So length of a tangent, it's up to you. You can draw short, you can draw long, but at least 5 centimeter, which will lead to a greater accuracy of the result. So whenever you draw a tangent, it should be at least minimum 5 centimeter long. It can intersect the x-axis or the y-axis, no problem. I can extend my tangent until it meet any of the axis, like x-axis or the y-axis. So the first point of the tangent on x-axis we call x1. The first point on x-axis, that will be x1. The second point on x-axis we'll call that as x2. The first point on y-axis we will call y1. And the second point on y-axis we'll call that as y2. And we'll work out the gradient. So the gradient, which is equals to y2 minus y1 over x2 minus x1, that is equals to the velocity. And when we solve that, our answer will be positive. But it's important to understand where to draw a tangent. So tangent, if you draw, like example, here I drew a tangent above the curve. What if a student try to draw a tangent below the curve, but it won't fit? Why? Because then the tangent will cut 2 points. So tangent is always, tangent is a line which touch a single point on the curve. That's why if I try to draw a tangent in this example from the bottom, it won't be a tangent. it will be a chord, but not a tangent. Is it clear how to work out the instantaneous velocity? Any doubt in this? It is a decreasing velocity, but instantaneous velocity means velocity at a very short instant of a time, short time interval. That's why, look, because the velocity is continuously changing, velocity at this point will be different as compared to velocity of this point. So we just work out a velocity at a particular moment of a time. That's why we call that as a instantaneous. So after drawing a tangent, find the gradient of that line, and that will be the instantaneous velocity. But what if you need an average velocity? How to work out an average velocity? So it will be a total displacement divided by total time. So average velocity will be the total displacement over total time. That will give us the average velocity. Like if I need the total displacement, irrespective of how it is done, we'll just draw a line to work out the total displacement and divide it by total time. That will give us the average velocity. So an object will have a different average velocity and the instantaneous velocity, because the instantaneous velocity is a velocity at a particular moment of a time, where average velocity is the average of the journey. An object may have an average velocity 0. If the total displacement is 0, definitely the object will have an average velocity 0. Is it clear, the concept of the displacement time graphs? Any question or a doubt you have related to the session today?
No, sir. Thank you.